Hello everyone! Today we will have a new lesson about data versus information, comparison and difference. In 1597, Sir Francis Bacon published the first appearance of this well-known, widely used phrase, knowledge is power. Certainly, he wasn't talking about information systems as we know them in the tech industry, but the phrase still holds a tremendous amount of significance as it acknowledges the valuable potential and capacity that comes with insightful information that becomes knowledge. But where does information come from? The technology ecosystem is data-driven and finding value in data is becoming critical for successful businesses, which is the topic at hand for this lesson, data and information. We cover data versus information to better understand their interdependence, their points of difference, and how one cannot exist without the other. Let's begin by defining each concept. When studying ICT, it is important to understand the difference between data and information. This study note tells you what the differences are and outlines the main types of information. What is data? Data is the complete list of facts and details like text, observations, figures, symbols, and description of things. It is the raw list of facts that are processed to gain information. The basic concept of data is associated with scientific research collected by different research organizations. Data can be a number, symbol, character, word, and if not put into context, individual pieces of data mean nothing to humans. Data is the raw, unorganized, unprocessed information. For example, the information collected for writing a research paper is data until it is presented in an organized manner. Data can be defined as a representation of facts, concepts, or instructions in a formalized manner, which should be suitable for communication, interpretation, or processing by human or electronic machine. Data is represented with the help of characters such as alphabets, capital letters A to Z, or small letters A to Z, digits from 0 to 9, or special characters such as plus, minus, slash, asterisk, less than, greater than, equals, and so on. What is information? Information is the data put into context. Information is utilized by humans in some significant way. A good example of information would be a computer. A computer uses programming scripts, formulas, or software applications to turn data into information. Information is the process, organized and structured data. It provides context for data. However, both the terms are used together. Information can be easily understood than data. In simple terms, we can conclude that data is an organized description and facts from which information can be extracted. Information is also organized or classified data which has some meaningful values for the receiver. Information is the processed data on which decisions and actions are based. For the decision to be meaningful, the processed data must qualify for the following characteristics. First, timely. Information should be available when required. Next is accuracy. Information should be accurate. And completeness. Information should be complete. Let's proceed to the data processing cycle. Data processing is the restructuring or reordering of data by people or machine to increase their usefulness and add values for a particular purpose. Data processing consists of the following basic steps: input, processing, and output. These three steps constitute the data processing cycle. Input. In this step, the input data is prepared in some convenient form for processing. The form will depend on the processing machine. For example, when electronic computers are used, the input data can be recorded on any one of the several types of input medium, such as magnetic disks, tapes, and so on. Processing. In this step, the input data is changed to produce data in a more useful form. For example, paychecks can be calculated from the time cards, or a summary of sales for the month can be calculated from the sales orders. Output. At this stage, the result of the preceding processing step is collected. The particular form of the output data depends on the use of the data. For example, output data may be paychecks for employees. What are the different types of data? Data can be of two types, the qualitative data and the quantitative data. Qualitative data, it is the non-numerical data. For example, texture of the screen, color of eyes, and so on. Quantitative data is given in numbers. Data in the form of questions such as how much, how many, gives a quantitative data. Let's talk about data versus information. The terms are sometimes mistakenly used interchangeably when in reality there is a clear distinction between the two. The major and fundamental difference between data and information is the meaning and value attributed to each one. Data is meaningless in itself, but once processed and interpreted, it becomes information which is filled with meaning. To put it into context, think of data as any series of random numbers and words that hold no meaning whatsoever. For example, 4A, 61, 6E, 65, 20, 44, 6F, 65, 2C, 0A, 34, 20, 53, 74, 72, 65, 65, 74, 2C, 0A, 44, 61, 6C, 6C, 61, 73, 2C, 20, 54, 58, 20, 39, 38, 31, 37, 34, 0A. Once the aforementioned data is processed, interpreted, formatted, and organized, you can see that it is the contact information of Jane Doe, such as Jane Doe for Street, Dahlias TX98174. Another clear example of the distinction between data and information are temperature readings from across the globe. A long list of temperature readings mean nothing of true significance until organized and analyzed to unearth information such as trends and patterns in global temperatures. Once data is analyzed, users can identify if the temperature has been on the rise over the last year or if there's a regional trend for specific natural disasters. Those types of discoveries are information that is extracted by analyzing data. Here's a comparison table to help pinpoint the key differentiators between data and information. So for the criteria, first the meaning. Data is raw facts that are the building blocks for information, while the information combine data filled with relevance and significance. As for the form, data is unorganized, while information is organized. For the basis, data is records and observations, while information is analysis. For the dependency, data does not depend on information. Information depends on data. For the measurements, data is for bits and bytes, while information, meaningful parameters such as time, quantity, dates, etc. Under significance and usefulness criteria, data alone has no significance, while information is always significant, useful, and relevant. For the specific criteria, both the data and information, both the data is no specific criteria, while the information is yes specific criteria. Another is for the meaning, data is raw, unorganized facts that need to be processed. Data can be something simple and seemingly random and useless until it is organized. While the information, when the data is processed, organized, structured, or presented in a given context so as to make it useful, it is called information. And for the example of the data, each student's test score is one piece of data. For the information, the average score of a class or of the entire school is information that can be derived from the given data. Under the etymology, data comes from a singular Latin word, datum, which originally means something given. Its early usage dates back to the 1600s. Over time, data has become the plural of datum, while information is an older word that dates back to the 1300s and has Old French and Middle English origins. It has always referred to the act of informing, usually in regard to education, instruction, or other knowledge communication. Another for the difference of the data and information are the following. Data is unorganized raw facts that need processing, without which it is seemingly random and useless to humans. Data is an individual unit that contains raw material which does not carry any specific meaning. Data doesn't depend on information. It is measured in bits and bytes. Data is never suited to the specific needs of a designer, and an example of data is a student's test score. While the information is a process, organized data presented in a given context and is useful to humans. Information is a group of data that collectively carry a logical meaning. Information depends on data. Information is measured in meaningful units like time, quantity, and so on. Information is specific to the expectation and requirements because all the relevant facts and figures are removed during the transformation process. And the example of information is the average score of a class in the information derived from the given data. Let's proceed to the 1 bit and 1 byte. As the base of measure for digital information, bits and bytes play a fundamental role in the subjects of data and information. Computers with their millions of circuits and switches use the binary system to represent on and off or true and false using bits and bytes. A bit, which is short for binary digit, is the most basic and smallest unit of data measurement in computer information, and it contains only two values, 0 and 1. Bits are usually designed to store data and execute instructions in strings of 8 bits, which is called a byte. The term byte was first coined by Werner Buchholz in 1956, and it represents this unit of data measurement, which is 8 binary digits long. All computers use bytes to represent all kinds of information, including letters, numbers, images, audio, videos, and more. Given that all information in computers is larger than a bit, the byte is considered the universal and smallest measurement size listed in operating systems, networks, and so on. What is raw data and how is it transformed into information? Think of data as a raw material. It needs to be processed before it can be turned into something useful. Hence the need for data processing. Data comes in many forms: numbers, words, symbols. Data relates to transactions, events, and facts. On its own, it is not very useful. Think of the data that is created when you buy a product from a retailer. This includes time in date of transaction such as 10:05 Tuesday 23 December to 0x3, or transaction value such as 55. Facts about what was bought, for example, hair dryer, cosmetics pack, shaving foam, and how much was bought. This refers to quantities. How payment was made, such as credit card number and code, which employee recorded the sale, or whether any promotional discount applied. At its simplest, this data needs processing at the point of sale in order for the customer to receive a valid receipt. So the data about the transaction is processed to create information. In this case, a receipt. You can imagine that the same data would also be useful to the manager of the retail store. For example, a report showing total sales in the day or which are the best-selling products. So the data concerning all shop transactions in the day needs to be captured and then processed into a management report. Information is the data that has been processed in such a way as to be meaningful to the person who receives it. Note the two words highlighted in red, process and meaningful. It is not enough for data simply to be processed. What are the uses of information in a business? First, planning. To plan properly, a business needs to know what resources it has, such as cash, people, machinery and equipment, property, customers. It also needs information about the markets in which it operates and the actions of competitors. At the planning stage, information is important as a key ingredient in decision making. Next, for the recording. Information about each transaction or event is needed. Much of this is required to be collected by law, like details of financial transactions. Just as importantly, information needs to be recorded so that the business can be properly managed. Next is controlling. Once a business has produced its plan, it needs to monitor progress against the plan and control resources to do so. So information is needed to help identify whether things are going better or worse than expected, and to spot ways in which corrective action can be taken. Another uses of information in a business is measuring. Performance must be measured for a business to be successful. Information is used as the main way of measuring performance. For example, this can be done by collecting and analyzing information on sales, costs, and profits. Next is decision making. Information used for decision making is often categorized into three types. First is strategic information, second is the tactical information, and third is the operational information. For the strategic information, used to help plan the objectives of the business as a whole and to measure how well those objectives are being achieved. Examples of strategic information include profitability of each part of the business, size, growth, and competitive structure of the markets in which a business operates, and investments made by the business in the returns such as profits, cash inflows from those investments. Next is the tactical information. This is used to decide how the resources of the business should be employed. Examples include information about the business productivity like units produced per employee or staff turnover, profit and cash flow forecast in the short term, or pricing information from the market. The third is for operational information. This information is used to make sure that specific operational tasks are carried out as planned or intended, like things are done properly. For example, a production manager will want information about the extent and results of quality control checks that are being carried out in the manufacturing process. How are data and information different? Information informs you of something, it answers a specific question, it represents a specific truth or fact. Data is the collection of recorded values from which information can be ascertained. For example, consider the question, what is the temperature outside? Data provides the basis for an answer to that question. If the data is 25.6 and Celsius, the answer is outside the temperature is 25.6 degrees Celsius. You must know what temperature is and what degrees Celsius are to process the data into information. Next is for the signal data and noise data. Some data is not relevant or informational. This irrelevant data is called noise. For example, if you create an audio recording of a piano concert, you might hear people in the audience coughing or the sound of a ceiling fan. These noises are irrelevant to the purpose of the audio recording, which is to record the sound of the piano. Information is analogous to a signal. In the example above, the relevant data is the sound of the piano. It answers the question, what did the piano sound like? The remaining data, or the noise, does not answer that question, so it can be ignored or removed. In terms of signal and data processing, signal processing is the separation of noise from a signal. A noisy signal is analyzed and the noise is reduced or removed to accentuate the signal or isolate it completely. Similarly, data processing identifies the meaningful data and separates it from the meaningless data. The meaningful data is then interpreted, combined, modified, connected, and structured into something new called information. Sample of data are UT 1234, Joe, Circle, SLC, 801553211, 84084, Smith. In this example, the original data appears to be a set of random words and numbers separated by commas. Example of information, Joe Smith, 1234 Circle, Salt Lake City, UT 84084, 801555211. In this information, the original data was interpreted, organized, and formatted according to predefined parameters. Now, the meaning of the data is clear. It is the contact information for a person named Joe Smith. Let's proceed for the information systems best practices to gain value from data. As proven, once data is normalized through the use of procedures, it is ready to be leveraged by an information system to give it meaning and utility. By employing a comprehensive information system, users can leverage the available tools, technologies, and techniques to help transform data into information that will eventually become insights or knowledge. As Techopedia defines it, an information system is the collection of multiple pieces of equipment involved in the dissemination of information. Hardware, software, computer system connections, and information system users, and the system's housing are all part of an IS. These components come together to store, retrieve, transform, and disseminate information. First, hardware. The computer itself along with its peripherals such as servers, routers, monitors, printers, storage devices, keyboard, mouse, and so on. Followed by software. The software system is what instructs the hardware what to do. The software collects, organizes, and manipulates data to carry out instructions. Next is the data or the databases, the information part of any information system. Data is critical. Next, network or communication, devices that communicate with each other to share information and resources. Next is the procedures, strategies, descriptions, policies, instructions, methods, and rules to use information system. Next is the users or people. This component is what glues together all the other components as they combine hardware, software, data, network, and procedures to generate valuable information. So information systems require a comprehensive strategy to deploy best practices to drive actionable insights. Some of these best practices include data integration, data virtualization, event stream processing, metadata management, data quality management, and data governance, to name a few. Data integration. Combining data from several sources into a centralized view. Data virtualization. Retrieving and manipulating data to deliver a simple, unified, and integrated view of data in real time. Event stream processing. Analyzing time-based data as it's created and before it's stored, even as it streams from one device to another. Metadata management. Administration of data that describes other data. Data quality management. Practice of identifying data flaws and errors and simplifying the analysis and remediation of data flaws. Data governance. Management of availability, usability, integrity, and security of data. That's all the discussions regarding the data versus information of its comparison and difference. Thank you for watching and have a nice day.